The Alldus podcast is brought to you by Alldus International, supplying your expert AI and digital transformation staffing needs across the US and Europe. Today, you are listening to our AI in Action series, where leading minds in AI from across the world share their story, success, and advice. AI in Action cuts through the hype and explores the true impact of artificial intelligence in our world today.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is Irv Lustig. Irv is the optimization principal at Princeton Consultants. Irv, welcome to the show.
Oh, thank you, JP, for inviting me.
Yeah, we're delighted to have you. So, Irv, let's start with yourself, please, if we could. Could you give us a bit of an overview of your journey in technology from where you first got started out, some of the interesting roles you've held along the way, and take us up to today as your role as principal of optimization at Princeton Consultants?
Well, you ask about technology. I think when I was a teenager in the 70s, I actually was working at a hospital where we were trying to computerize the surgical intensive care unit. And we were doing it with microcomputers, which were on the Altair 8800s that predated the IBM PCs that came out in around 1981. Then I went off to college, got a degree in applied math computer science, and then went off to Stanford University and got a PhD in operations research, which is the home area for my specialty in optimization. My PhD advisor was George Dantzig. He is who's known as the father of linear programming. He created a fundamental algorithm that many people have heard of. Many people have not, called the simplex algorithm for linear programming, and it was an honor and a pleasure to be able to study under him. After that, I spent 6 years teaching at Princeton University, and then I joined a small company called Cplex Optimization Inc. in 1993. I was employee number 7, was one of the original developers of Cplex, which became the industry standard for mathematical optimization up through pretty much into the 2000s and 2010s. Cplex was later acquired by iLog, which was then acquired by IBM in 2008. And during my time at iLog, I stretched roles from being a developer to being a product manager to, at the time of the IBM acquisition, I was leading the sales and outbound marketing for our iLog's optimization and visualization products. And then I spent a few years at IBM. We were integrating the business. Then in my last 3 years at IBM, I went back to doing more technical things and was in IBM research, investigating connections between predictive analytics and optimization. And then at the end of 2014, I came to join Princeton Consultants after being on the side of selling the technology and kind of the algorithms and the techniques that are used for solving optimization problems. Went on the other side to be more into the application areas, where we look for applications of optimization and let people really see the benefits by leveraging these engines and building applications that solve these problems.
Excellent. Thank you for the overview. And it's great to learn that you've been in it since the early adoptions of automation and getting insight into some of the early amazing work at IBM. You touched on it there. You've been with Princeton Consultants since 2014. I want to jump into your role in a bit more detail and what brought you to Princeton. But let's first take a step back. Tell us all about Princeton Consultants as a business, who you are, what you do, what's the mission of the business.
So Princeton Consultants, we've been in business over 40 years. We're based in Princeton, New Jersey, with an office in Manhattan. Our tagline is management, consulting, and information technology. So when the business started, it was more on the management consulting side, and the founders were looking at ways that computers could be applied to help solve different types of problems. That was back in the 80s. As the business evolved, there was a recognition that optimization in particular could be used to improve companies' ways of doing business and making decisions. And that now is expanded into doing more advanced analytics of what people now call machine learning, data science, AI, which optimization falls under any of those umbrellas, depending upon how you want to look at it. So our mission today is to work with companies that really need help in automating decisions that are about in optimization, which are about making best decisions about how do you allocate limited resources. Most of our work, both non-analytics and our other work, is actually in the transportation area. We have done work for all of the major railroads here in North America. We do a lot of work in trucking and intermodal trucking, but our work in advanced analytics and optimization goes from media to sports to healthcare. It just spans the gamut. Supply chain. We do work in all of those areas and helping people recognize and leverage the benefits of these technologies to make better decisions.
Thank you for the overview. And obviously, there's a lot to unpack there with Princeton Consultants working in the early days as what was now referred to as machine learning. But you touched on it there. It's all about optimization of processes within business. Talk to us about your role then. You're the optimization principal. So that brings out a lot of responsibilities. What does the role entail? What's your day to day look like? And walk us through a typical project with you and your team working with some of the customers on the problems that they have for you guys to solve.
So I came here really recognizing after my years of doing things and leading a sales effort and not doing much stuff technical to then switching at IBM, I decided to go back to doing technical things that I really needed to do a little bit of both. So here at Princeton, that is my role. Is one is to work with our business development folks on developing opportunities, working with partnerships. We have partnerships with a number of technology vendors in the optimization space. And when we get opportunities to start them off from where they think they have an optimization problem or they have a business problem to solve, and moving them through the sales process to convince them that we can help them build out a solution to solve their problem. Once we've done that, I'm then involved in the technical side, typically leading the efforts on the architecture and design and the implementation of the optimization-based solutions. And that can range from doing the optimization part. Of course, it's a huge part of it, which is working with data, getting it organized and figuring out how to do things. Lately, we had a project now where I've gotten into the side of deployment into the cloud with Kubernetes and figuring out how do we make optimization work in that kind of environment, which was a new application of cloud technology for our optimization. So I end up spanning the gamut of the front end of trying to help make a sale and get us a project for consulting to the actual and being involved in the implementation. So it's a healthy mix of the two activities. So on the sales side, aside from writing proposals and helping, sometimes we end up responding to requests for proposals or writing up potentials, doing assessments of, we do typically start with a project where we may assess what is necessary to be able to build out a full solution. So we sit by our customers, watch them making decisions and trying to figure out how we can apply optimization. Then the project will then move into building out a team that's going to build out an application with user interfaces and databases and the optimization and being involved in that. And then we worry about deployment, which has two aspects. One is the technical aspect of how do you stand up an application either in on-premise or in the cloud, but also the business aspect of deployment. And this is where our management consulting skills come in, where we look at and say, if we're going to give people a new decision support tool to make better decisions, how is it going to affect the other parts of the business? Some people who were spending a week putting together a schedule on a spreadsheet will now get a schedule in a minute. So now what are they going to do with their job? Or if you're going to be scheduling people and you can figure out that you can use less personnel, you have to have a conversation with the HR department about, hey, this new optimization technology is going to tell you you need a smaller workforce. You need to plan for that. So we think about these downstream effects in the business of the deployment. My day-to-day work involves sometimes ending up building out proofs of concepts to working on proposals to being involved in the deployment and architecture and solution building of the solutions we do for our clients.
I want to now understand the other side of it, the implementation, the team that you work with in Princeton Consultants, because obviously your role is a combination of working with the customers and working with your salespeople to identify opportunities. But once you secure those opportunities and you bring on a customer for a particular project, there's the implementation and support phase. I'd love to have you walk us through what an example of a recent project or a typical journey would be from the time of bringing in the customer to helping them understand the various types of optimization options available to them, and then how you and your engineering and data team help them go and implement it and have it run successfully.
So typically what occurs is, as I mentioned earlier, we start off with one of these assessment projects. So we'll go in, we don't know the size of the effort that's going to be needed. We have to determine with the customer's IT department, how much are they going to bring to the table? They may have standards. They may have people who do all the user interface work, or have certain things that they have to be in control of databases. So we have to assess how much work are we going to have to do in order to bring this solution and the vision of a solution to reality. Once we've estimated that, now we're ready, and now we say, okay, it's time to start the project. We bring together generally a pretty small team. It can be anywhere from 2 to 5 people. That will be typically somebody's always doing some user interface work. There's work to do in terms of databases and data management and massaging and cleaning data and building out pipelines that come from data sources into an optimization solution. Then, a lot of software engineering to go out and build out the solution, to go through the typical stages of development and then user acceptance testing and then pushing things out to production, done generally from our standpoint with small teams. And it can range from, most of the time our applications are ending up being used by just a few people at our customers. We're actually in the process right now of, in the midst of deployment. I mentioned earlier about the Kubernetes example of deploying an application to a healthcare company that has 3,000 facilities, and they're going to be scheduling their patients and their technicians to work in each one of these facilities. There's going to be a user, the facility administrator, in each one of these 3,000 places that's going to use this application to work on and modify and work with the schedules. So we've done some limited beta testing with a handful, more than a handful, it was about 20 to 30 of the facilities who really love the idea. It's going to save them so much time. It's going to produce better schedules. And now we're collaborating with their deployment teams on how this application is going to get deployed on the technical side, but also how are they going to train all the users to use the application and understand how it works, and how do you build a support infrastructure so those users we're going to be probably the level 2, level 3 support, that we now have to work with their support teams that support applications for this big company so that they know how to ferret the issues to us. Whereas if somebody says, I'm having trouble logging on, their support department can handle that. But if they're seeing something that's funky with the results of the schedules that we produce, they eventually route the issue over to us. So we end up working on all of these kinds of technical issues with the teams in order. The goal is to build an application that's effectively a decision support system, like the scheduling application I just mentioned, that's going to help people make better decisions and understanding the user profiles of the users that will be using that application.
You are listening to the Alldus podcast. When you're looking to scale your team, or if you are interested in showcasing your company in a future episode, reach out today. Or if you're in the market for a new role, visit our website to view open positions, www.alldus.com.
A lot of what we talk about on this podcast here is cutting through the hype behind AI. And unfortunately, there's a high failure percentage on AI and data science projects simply because organizations are trying to tackle the complicated things without first fixing the fundamental data quality issues and focusing on the more basic things that they could benefit from. I'm sure in your role, a lot of which is educating customers on what they need to do first before they tackle the really shiny and exciting stuff. Can you talk about some of the most common misconceptions you come across when you're speaking to companies about what they need to do short term before they try focus on longer term projects?
So what we see a lot, and I have people that I know that are in the field and out there, there's some line, I think it comes from Gartner, about 85% of AI projects fail. The thing that I've seen, and I think we've learned here at Princeton over the many years of doing this, is that there tends to be now is if you hand me data, I'll make some magic happen. And the answer is that no, it doesn't work that way. The right way to think about it is to say, what is the business problem or question you're trying to answer? What process are you trying to improve? Identify the problem, right? And then determine what data do we need in order to be able to address that problem and solve it. And so we try to change the discussion from a technology discussion of whether we should be using TensorFlow or this tool or that tool or this optimization engine to what is the business problem you're trying to solve? Let's figure out, if we're to solve it, what the benefits will be. The benefits in the cases of optimization are often in the hundreds of millions of dollars of cost savings, and that are just fantastic. But sometimes the benefits are that people will just be more efficient in their decision making, like in that healthcare scheduling example I just gave. They're hoping to have better schedules that will mean that their staff will have less hours to treat the same number of patients, which will then reduce their costs. The other benefit is that their facility administrators now are not going to spend days figuring out schedules, and they'll get something very quickly and can be moving on to things that improve their overall patient care. In terms of the success factor of our projects, we really try to focus on the business problems. The other thing that we do as part of our practice is we have what's called the Princeton 20. And what this is are 20 different risk factors that we assess on each of our projects as early as we can. 10 of them are environmental factors, things like, is there a business sponsor? Do they understand how to quantify decisions and how valuable one decision is versus another? On the technical side, it's things like, do they already have a system in place? Are they used to making decisions based upon AI-based systems, or is this totally new? Are we solving a problem where we're bringing in some very hot new technology that's only barely been proven, and therefore that represents a risk? So we assess these 20 factors from the risks, and then we look to, at the beginning of the project, say, you have to have mitigation actions for each one of these risks right up front. Don't wait until something goes wrong when you're 10 months into the project. Let's make sure on day one, we all understand these are the risks and that we have to put an action plan in place to mitigate those risks, because based on our experience on doing lots and lots of projects, we know what can go wrong, and we want to make sure those things aren't going to go wrong downstream. So I think our education process with our customers is to go through and try to really do that risk assessment as much as we can with our Princeton 20 to determine this is the path to success for a successful project. And then the technology is a means to an end to realize the vision of the benefits that they can get.
So important to hear, and I think it can't be said enough for anyone listening, is to focus on the problem that you're trying to solve first, and then let that lead what tools, approach that you use, as opposed to the other way around. I want to spend the remaining few minutes we have here talking about what's next, not just for Princeton Consulting, but from your take on the industry as a whole. When you look at the next 3 to 5 years and some of the things that are coming down the pipeline, what are you particularly excited about for the work that you're going to continue to do at Princeton, but then new emerging trends that you expect to see happen in the industry as a whole across AI?
So what we've seen in optimization, I've been doing this for my 30 plus years now, is that the underlying algorithmic technology, which I was part of when I was part of the CPLEX team, has improved by magnitudes more than the hardware that we're running it on. And if I go back to when I was doing my PhD thesis and finishing up in 1987, there was a hard problem back then that we'd have a mini computer solving, and it would take 24 hours to solve it. And today I can solve that same problem on my laptop in less than a second. And it's not just because the laptops are faster than our old mini computers. It's because the algorithmic improvements are orders of magnitudes in terms of what's happened. So what that means is that we're now able to make decisions more in real time. So optimization has traditionally been used in a more strategic approach. For example, companies will, in the supply chain area, will decide where they should create their distribution centers in order to ship products to their customers. That's a strategic decision. You say, okay, I'm going to build a new distribution center. It takes a year to build a facility. You don't make that decision every day of the week. On the other hand, now you want to start making decisions as your orders are coming in an e-commerce industry. which distribution center should send that order to the customers in order to reduce our shipping costs. So we worked with one e-commerce vendor that's making this decision 24/7. So every few minutes they decide on 500 to 1,000 orders which distribution center should send it to which customer in order to reduce their overall shipping costs while keeping a balance of work across all the distribution centers. So we're seeing decisions now made by optimization that have moved from the strategic to the tactical to now the more operational, where they're starting to get made more in real time. And that's because of the underlying algorithms getting better, underlying computing power being more available, and the available data allows us to help start making better decisions. So I think we're going to continue to see this evolution of people realizing that there's applications of this technology of making best decisions about how to allocate your limited resources being done in real time. We're starting to see now people doing more types of scheduling applications like the one I mentioned in a healthcare facility. We're working on an opportunity right now with another company that's looking to schedule their personnel. It's all done in spreadsheets, and they spend months coming up with an annual schedule. And then as the schedule evolves during the course of the year, things happen. They have to modify the schedule, and they have people full time just coming up with scheduling decisions. We can automate this really, really easily and create an application that allows them to handle these modifications in a real-time basis. So I think we're going to start seeing in the future more of these types of real-time applications in the scheduling area and allocating of resources where people have to make decisions leveraged by the optimization technology. And I'm using that as because that's my area of specialty. I think in the AI arena, everybody's going to people are looking for rapid response. How fast can I make decisions? How fast can I get information? We're so used to this world of having our phones and being able to get anything very quickly. We want to be able to make decisions quickly. So the technology and the applications have to evolve to be able to support more real-time decision making, where you don't have to wait hours to make a decision, but I can get decisions about what's the next best thing that I can do now with my limited resources, and optimization can be a key to delivering that.
Final question for me then, Irv. Speaking to an audience of data professionals who are always on the lookout for interesting organizations to potentially further their career, you sit at a unique point where you can talk about being on all sides of the table, the sales side, the buyer side, the seller side, and working in Princeton, it's very much a solution-oriented organization. What message would you have for data scientists, data engineers, or just overall data professionals who maybe haven't considered working in the consulting world, and why an organization like Princeton Consulting can really help further their career?
So if you're a data scientist, you're typically working for a single company and in a single industry on a single set of business problems. And one of the fun things I like about being here at Princeton is that I'm getting exposed to multiple industries and multiple different kinds of problems all the time. There's a continual learning, not just about the technology, but also about the kinds of applications of the technologies. And you meet some very interesting people in different industries. People react different way, and it's a very human relationship. So what's great about consulting and working on solution development of these problems is that you develop good social skills. You get to relate to people. Now that we didn't travel for a couple of years because of COVID, but now we're getting back to traveling again and going in their environments, and you see how things are different from industry to industry and how people make decisions and how they move business forward. So the fun thing about being in consulting is probably the variety that I get. I get asked often, I get hit by headhunters who work for this X, Y, or Z company. And I think to myself and I say, yeah, you've got a bunch of interesting problems, but it's all in one very narrow industry. And what's exciting about being in here is this variety of different things that we get to be exposed to. The consulting career is valuable in that regard. It really helps. And I think it helps for me. I had a lot of experience before coming here, but I look at the folks that we hire in and we see them grow within the company. That helps grow their own skills so that they can be leaders. because they learn how to interact with people, work with people, and more of the soft side of developing successful applications of this technology, and not just only worrying about only the data all the time.
Irv, thank you so much for today. It was great to talk to you. Great to learn about your background. Amazing to learn about the work you're doing with optimization at Princeton Consulting. There's a real clear focus there on solving business problems, and it's clearly evident that with the work that you're doing and some of the customer stories that you mentioned. So we wish you, the team, everyone at Princeton Consulting, the best of luck in months and years to come, and we look forward to having you back on the show in the future.
All right. Thank you for having me, JP.
Thanks for listening to this episode of the Alldus podcast. If you enjoyed today's episode, don't forget to subscribe, rate, and review. We are available on Apple Podcasts, Spotify, and any Android podcast of choice. You can also head over to our website, www.alldus.com, to listen to more podcasts, view our open roles, and stay up to date with industry news. Thanks for listening, and stay tuned for more great episodes coming very soon.